Larry and Mo, the top students for Block 2, scored 76 and 78 in their exam in psychological assessment, respectively. Assuming that the test has a reliability coefficient of 0.92 and a standard deviation of 5, can we conclude that Mo performed significantly better than Larry? A. Yes, with 68% confidence that their scores represent true score differences. B. Yes, with 95% confidence that their scores represent true score differences. C. Yes, with 16% confidence that their scores represent true score differences. Or D. No, insufficient data. And the correct answer is letter A. Yes, with 68% confidence that their scores represent true score differences. Ha? Di ba ang standard deviation ay 5? Paano naging 68? In this case, we are not talking about standard deviation only, no? Since we are asking if Mo performed significantly better than Larry, we are here talking about standard error of the difference. So what is standard error of the difference? It is a statistical measure that can aid a test user in determining how large a difference should be before it is considered statistically significant. Basically, gaano ba dapat kalaki yung lamang or yung kulang sa dalawang scores para masabi mo na statistically significant na yung difference nila. How do we go about calculating this? So let's start with a given. Larry scored 76, Mo scored 78, we have an SD of 5 and a reliability coefficient of 0.92. Standard error of the difference is calculated with SD times the square root of 2 minus R1 minus R2. R1 and R2 is just the reliability coefficient of the two scores. Since we are comparing them from the same test, we will be using the same R1 and R2. So both of them will be 0.92. So crunching the numbers, 5 times square root of 2 minus 0.92 minus 0.92, we have 5 times 0.4, which is equal to 2. So our SED is equal to 2. But how do we calculate for the confidence interval? Well, for that, we use the normal curve. So, ang pag-calculate sa kanya is that parang nung sa standard deviation lang, no? Like, 1 SD is equal to 68%. So, makikita nyo dito sa normal curve, it's just adding the 34.1% and another 34.1%. And then, another one is 2 SED is 95% confidence. You just add starting from 13.6 here and another for 13.6 here. And then 3 SED is 99.7% confidence. So, I'm sorry, but my normal curve I'm using is very limited right now because I don't have like access to the more detailed one. This is the only one that could be used publicly and for free. But I'm sure you've already seen one normal curve in your life. You're an aspiring psychometrician or psychology professional and it's a very familiar concept for you. So, yun lang yun, no? That's how you calculate for the confidence interval of SED. So, remember, when we are asked how large a difference should be before it is statistically significant, we are talking about SED. So, you have to calculate SED when you are asked that question. In general, the higher the reliability of a test, the blank. A. Higher the SEM, B. Lower the SEM, C. Higher the mean, or D. Lower the mean. And the correct answer is letter B. Lower the SEM. So, tinatanong lang naman natin dito talaga is what is the relationship between reliability and standard error of measurement? Well, basically they are opposite because reliability is a question of precision. Meaning, kung 100% ang reliability mo, 100% ang precision mo, you scored 50 on a test, that means 50 ang true score mo or yun yung true ability mo or true knowledge mo, whatever the test is about. But that never happens, of course. There is always some error that happens when you test. Maybe kabado yung test taker, or napuyat, or anxious, whatever. There's always an error. And that error, that is what we call the standard error of measurement. Basically, it's the amount of error in your test, in the measurement of your test. It's the imprecision. So, comparing them, we have reliability, a measure of precision, and SEM, a measure of imprecision. So they go hand in hand. So how do we go about proving this? The standard error of measurement is calculated by standard deviation times the square root of 1 minus r. Let's say we have 3 different scenarios where standard deviation is kept constant and we change the reliability coefficient in 3 different scenarios. So as you can see in this, in the first one, r equals 0.1, we have an SEM of 0.949. With the second scenario, we increase the reliability to 0.5, we have an SEM of 0.707. And for the third scenario, with a reliability of 0.9, we have SEM of 0.316. So as you can see, as we increase the reliability, bumababa yung SEM. And if you make reliability equals 1, mapapansin mo, the SEM would be 0. Kasi nga, kung perfect ang reliability mo, perfect yung precision mo, edi walang error. And of course, that will never happen. If you ever have a test like that, edi ikaw na. pero wala kasing ganun. Kailangan mong ulitin yun kasi something is probably wrong either with your test, the way you administered it, or maybe mali yung pag-crunch mo ng numbers in terms of calculating it statistically. Or something wrong with the machine you're using. Whatever. Pero walang test na walang error. So, if you ever came across something with a reliability of 1.0, good luck with that. That's just impossible. It doesn't work. Laging may error. There's always something that could go wrong. Let's talk about important terms first. So, standard deviation, when we talk of standard deviation, it means the standard error of the sample. That's why we don't want to be making conclusions based on standard deviation alone. Because we want to be able to make conclusions about the population. Because if we make conclusions based on the standard deviation alone, we are making a conclusion only based on the sample. And it may or may not be applicable to other people. Right? Maybe limited lang siya sa context ng research mo or nung ginagawa mo. And we don't want that. We want our work to be used by others. So we want to estimate for the population. And to do that, we have to measure the standard error for the population, and that's what we call the standard error of the mean. Another one is the standard error of measurement. Sinabi ko na yun kanina. That's the extent to which an observed score deviates from a true score. Yan yung measure of imprecision mo. Standard error of the estimate. This is usually in regression analysis where you identify the relationship between the variables x and y. And then, syempre, you are trying to make a prediction. And then that error in prediction, that's what we call standard error of the estimate. So that's also what we call a standard error of prediction. And then, of course, standard error of the difference. That is how large a difference should be before it is considered statistically significant. We talked about that in number 1, and that's the standard error of the difference. The appropriate reliability estimate to be used for this psychological assessment drill would be A. Cronbach alpha, B. KR20, C. KR21, or D. Test-retest. And the correct answer is letter B, KR20. So why not test-retest? Well, basically it is possible to use test-retest, but we want to refrain from administering this test twice to the same test taker because that would be an error. There will be an error there because you will become familiar with the items in the test. Maybe a more appropriate one if we want to conduct 2 administrations would be parallel tests or alternate forms. We make another test that are considered equal with this test and then we administer it again with the same test taker. So that walang bawas yung error na nagiging familiar ka dun sa item. Like if you just take this test again with the same items in the same order with the same choices, more likely mas matatama mo na yung ibang questions na nagkamali ka. Lalo na if we make a delay of 2 days or 3 days. Right? So we want to refrain from test-retest. It's not the best reliability estimate in this scenario. So let's discuss the other three inter-item consistency. So why not Cronbach alpha and KR21? So if we compare KR20 and KR21, both of them are used when there is a right or wrong answer in the test, or basically they are used for dichotomous test, true or false or right or wrong test. And the major difference between KR20 and KR21 is that KR21 assumes that all items are of equal difficulty. And we really have no way of establishing or making that assumption in this case because we will be talking about validity, reliability. I mean, can you really say that item 1 is almost of equal difficulty with item 2? Like, the first one asks to calculate the numbers, crunch the numbers, and then make some other concepts like confidence intervals, SED, and whatnot. And number 2 just asks you about the relationship between reliability and SEM. Do you say that they are of equal difficulty? So it's hard to establish, right? We have not established that, and since we have not established that, we have no reason to assume that, so we use KR20. But why not Cronbach Alpha? Well, it's not Cronbach Alpha kasi Cronbach Alpha is used for non-dichotomous test. Basically, walang tama o maling sagot. So, kung mapapansin nyo sa mga personality test, madalas nating naririnig yan, the value of the Cronbach Alpha for this, blah 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 blah, that's why we call this test reliable, etc. etc. That's because sa personality test, walang tama o maling sagot. But, if you have a test with the right or wrong answer, it is more appropriate to use Kuder-Richardson or KR20 or 21, depending on the assumptions you are willing to make regarding the test. Assume that all items in this test are of equal difficulty. The appropriate reliability estimate would be A. Cronbach Alpha, B. KR20, C. KR21, or D. Test-retest. The correct answer is letter C, KR21. Again, we are assuming, although it's not a warranted assumption, that's what the item is asking, if we can assume that all items in this test are of equal difficulty, and this is a right or wrong test, we use KR21. Using Taylor-Russell tables, one must consider all the following variables except A. Test validity, B. Test reliability, C. Base rate, or D. Selection ratio. And the correct answer is letter B. Test reliability. Huh? Paano ka naman sa gagamit ng Taylor-Russell tables kung hindi reliable yung test mo? Yes, it makes sense. Reliability is always important. You need reliability before you can have validity. But, big but, we are talking about Taylor-Russell tables. I'm merely asking which are the things that you use so that you could make a Taylor-Russell tables, and it doesn't consider test reliability. Of course, you need test validity, but if the test is already valid, then it must be reliable as well. But we don't consider test reliability with Taylor-Russell tables. So what is Taylor-Russell tables? It provides an estimate of the extent to which inclusion of a particular test in the selection system will improve selection. So ganito lang yan, no? Let's say you have a company and then 3 out of 10 salesman na hina-hire mo, yun lang yung satisfied ka sa performance. Yung mga yung pitong na-hire mo dun sa 10, kamote. Hindi maayos performance, underperforming, hindi nakakabenta. And then suddenly you came across this test which we call salesmanship test. So you want to figure out, kapag ginamit ko ba itong test na to, ano bang mangyayari sa selection ko? Right? Maybe magiging 6 out of 10 na, or 7 out of 10, or 8 out of 10 na yung magiging satisfied ka na performance when you use the test. And to do that, we need to consider 3 things. First, test validity. We use the validity coefficient of the test. Next is selection ratio. Yan lang yun. Selection ratio is basically ilan yung hina-hire mo out of all your applicants. So kung isa lang yung hina-hire mo tapos 100 yung aplikante mo, swerte mo, dami sa'yo nag-apply. So sa 1 in 100, so that's your selection ratio, 1 in 100. Base rate is basically dun sa previous example ko, that's the 3 out of 10. So nung hindi mo ginagamit yung test, 3 out of 10 lang yung nagiging successful hires mo. And once you crunch the numbers and you calculate that, depending on your selection ratio and your test validity, you will find out how much that test would increase your selection. Maybe maging 6 out of 10, 7 out of 10. Who knows? Depende dun sa values ng numbers. An blank is a relatively large and easily accessible collection of test questions. A. Item pool, B. Item bank, C. Question database, or D. Test database. The correct answer is letter B, item bank. So ito yung mga choices ko dyan, yung item pool, question database, test database. Keme-keme ko lang yan, walang ganyan, no? Item bank. This is the definition of item bank. The ability of the computer to tailor the content and order of presentation of test items on the basis of responses to previous items is called A. Computerized adaptive testing, B. Item branching, C. Computer adaptability, or D. Item flexibility. And the correct answer is letter B, item branching. So, yung C and D, wala lang din yan. Invento ko lang yung choices na yan. Wala naman talagang computer adaptability and item flexibility. Yung computerized adaptive testing, that is what we call the administration of the test. That's how it is administered. But since I was asking for the ability of the computer to tailor the content, we are here talking about item branching. Computerized adaptive testing, that is a form of administration. So, para lang yung pen and pencil. Board exam is a pen and pencil test. And then there is also computerized adaptive testing wherein we use computers to administer the test so that we are able to find out a certain variable. So, let's say IQ test, bibigyan ka ng computer na, kumari, 150 ang IQ mo, bibigyan ka muna ng computer na item worth for 80 points IQ. Syempre dahil matalino ka, tama yun. And then 110, 120, 130, hanggang sa 150 ka. And then bibigyan ka nun, syempre tumama ka, 150 IQ mo eh. So bibigyan ka niya 155 or 160. Dahil beyond na yun sa level of IQ mo, magkakamali ka na. And then bibigyan ka niyan ulit ng ganung item, magkakamali ka. And then babalik na siya dun sa 150. So basically it's adjusting based on your ability. And the ability of the computer to do that is item branching. In the form of administration, that is computerized adaptive testing. Item branching is the ability, computerized adaptive testing is the administration. A T-score of 70 is equal to blank percentile. A. 97th, B. 70th, C. 84th, or D. 99th. The correct answer is letter A, 97th. So how do we calculate for this, no? So first, let us distinguish between percentile and percentage. So let's say you scored 90% in a mathematics test. 90%, it means out of 100 items, 90 yung tama na nasagutan mo. That is 90%. Pero pag sinabi ng teacher mo, you scored 90th percentile on your math test. Congratulations. That means you performed better than 90% of the test takers. So kung 100 kayo sa klase, 90th percentile ka, 90 people ang tinalo mo. You are the 91st. Pero we can say na you performed better than 90 people. So kung 99th percentile ka, you performed better than 99% of the test takers. So how do we calculate this percentile using T-scores? Well, we convert it into Z-score. How do we convert to Z-scores? We convert to Z-scores using this formula. Observed score minus the mean divided by the standard deviation. So the mean and SD here is not the mean and SD of Z, but the mean and SD of the standard score you're using. Since we are using T-score here, we will use the mean of 50 and a standard deviation of 10 because that is the mean and standard deviation of T-scores. That's a given. You should know that. Calculating that, looking at this normal curve, we have a total of Z equals to 2. So, pag tinignan nyo itong normal curve na to na 2, makikita nyo dito, pag inad nyo yan lahat, starting with the 2.15% up to the number 2, doon sa 13.6%, makikita nyo ang total niyan is 97% approximately. So we have a 97th percentile. If it's a Z-score of 1, edi i-add mo lang siya hanggang dito sa 34.1% sa right side. So that is a total of 84%. A Z-score of negative 1 is equivalent to a T-score of A. 60, B. 80, C. 40, or D. 20. The correct answer is Letter C, 40. So, dito naman sa item na to, we are just doing the reverse. When we say the reverse, well, you are now converting from z-score to another standard score. From z to t. So, how do we do that? Well, we use another formula. We use mean plus standard deviation times z. We are using mean and standard deviation here again using the standard score. In this case, it's the t-score. So, what's our z? Negative 1, right? So, we have 50 plus 10 times negative 1. Therefore, 50 minus 10. We have a total t-score of 40. Why is this important? Well, because it allows you to compare. It's important to be able to transform any score you had to a z-score or to another so that you can compare them. Mostly for z-scores, no? So, let's say nag-conduct ka ng study and then you have a mean of 40 and then a standard deviation of 3, right? So you want to compare, let's say, test taker A to test taker B. So you can actually compare them using the z-score. You can now see which one performed better than the other. So ito, we have a table here. I want you to take a picture, copy this, take notes of this, memorize this, because these are givens and they are rarely stated in the questions, if ever they were ever stated at all. But these are the usual standard scores that you will see as mentioned in Cohen's word list. So, z-score, t-score, STA 9, 10, GRE, SAT, and IQ. The optimum difficulty for a voice choice test is approximately A, 0.5, B, 0.325, C, 0.625, or D, 0.75. And the correct answer is letter C, 0.625. So, ito we are only talking about optimum difficulty. When we say difficulty, it means it's the number of test takers that got an item correct, right? And when we say optimum difficulty, yan yung average difficulty sana nung test na gagawin mo. Meaning, maybe may mga easy items ka na sasagot ng 100%, and maybe may mga difficult item ka na nasasagot lang 30% of your test takers. But on average, they should be approximately 0.625. Why? Because in a 4-choice test, there is always a probability of getting the item correct of 1/4. Right? In short, pwedeng chumamba. Right? So, sa mga cases na pwedeng chumamba, we make a calculation of that using this formula. 1 plus the probability of guessing divided by 2. So, the probability of guessing is that 1 divided by the number of choices. So, 1 in 4, right? So, we have a 24% probability of guessing. We have 1 plus 1 over 4 divided by 2. We have 1.25 over 2. And that is a total of 0.625. So, kung 5 choices siya, you just change it. You just change it to 1 plus 1 over 5, etc. etc. So, it's important to identify the optimal item difficulty so that when you make a test na, what if, multiple choice siya, 4-item test. Ideally, you analyze the items and you try to improve it, and then you try to converge it to the optimal item difficulty. So, hindi na, kumari, sobrang hirap, lumagpas ka sa 0.625, mas mababa, ang difficulty mo lang ay 0.3, 30% lang yung average na tumatama dun sa test mo. Well, you have to make it easier. And if it's very easy, na lumalagpas ka naman sa 0.625, maybe 0.8 na yung average item difficulty mo, you have to make it more difficult. So that's the usefulness of knowing the optimal item difficulty. Which of the following types of validity is not important? A. Face validity. B. Criterion-related validity. C. Content validity. Or D. None of the above. And the correct answer is letter D. None of the above. Well, I'm asking which validity is not important. Well, all validity is important. Even face validity. You might think, wala naman tayo kino-calculate sa face validity. Or, it makes sense, no? Personality test nga naman yata itong personality test. Parang it just makes sense to the test taker na what they're doing is appropriate and useful for them. It's to build rapport or to arouse the interest of the test taker. And that is useful. Why? Because our profession is talking with humans. And humans do not cooperate sometimes. And face validity, making the test seem more interesting for the test taker would allow us to gain their cooperation. And that's really important. Because if they do not cooperate, how can you expect an accurate and reliable diagnosis or psychological report or psychological evaluation? It's difficult. Like, they're lying to you, good luck. Good luck sa psychological report mo kung nagsisinungaling sa'yo yung client mo. So, you need that. You need face validity. Criterion-related validity, this is very statistical. You know, usually grades, may criterion, pass or fail, by criterion. So, well, we calculate the numbers, we solve it, we figure it out, crunch the numbers. Of course, it's important. Content validity, does the test represent the construct? Well, of course, how can it not be important? Let's say gumawa ka ng test sa depression. And we know that an important symptom of depression is the 2-week rule. Like, you should be experiencing the symptoms within 2 weeks or more than 2 weeks. Or you have anhedonia and the other symptoms like sleep deprivation or insomnia or hypersomnia, difficulty concentration, blah blah blah. But what if yung test, gumawa ka ng test sa depression, wala kang question about anhedonia? Kulang yung test mo, kulang ng isang symptom. Hindi ka nagtanong about whether the patient or the client is experiencing anhedonia. Well, that will skew your results. Iisipin mo, severely depressed na pala, pero nag-e-enjoy pa sa buhay yung tao, or ang dami pa niyang pleasurable activities na na-experience sa life. Ang saya-saya pa niya. Because you did not ask for anhedonia. Right? So yun, that's content validity. Another one is construct validity. It's not in the choices, but basically construct validity is that nag-test ka for anxiety. Construct validity is literally, anxiety ba talaga yung tinetest mo? Or maybe something else, no? Baga, sakto ba yan na talagang yung, are you sure na yung concept ng tinetest mo is about anxiety? Baka naman depression yan, schizophrenia, or something else. But it's not really anxiety. So that's construct validity. Having a construct validity in your test means that it's really accurately measuring the construct you are saying it measures. So if it measures intelligence, it measures intelligence. If it measures personality, Big 5, it really measures the Big 5. A general electronic reaper test that measures knowledge of digital video recorders, Blu-ray players, MP3 players, and satellite radio receivers is expected to have blank. A. High inter-item consistency. B. Low inter-item consistency. C. High test-retest reliability. Or D. Low test-retest reliability. The correct answer is letter B. Low inter-item consistency. So, inter-item consistency, when we say inter-item consistency, basically ganito yan, no? Kapag nag-split half ka kasi, hinati mo yung test from even odd, tapos kinorelate mo sila, makikita mo doon yung relationship nung test A and test B, yung other half ng test. Ngayon, ang inter-item, basically, hinati mo lang siya ng hinati to the extent na kinompare mo na lahat ng items. Gaano ba kung consistent yung items? So let's say I'm testing for anxiety and you are really an anxious person. Therefore, kung yung items ko consistent talaga siya, if all my items are really measuring anxiety, from a scale of 1 to 5, tapos 5 yung anxiety mo, dapat sa lahat ng items, 5 yung score mo. That's what we call consistency. Because we established that the items are measuring the same thing. It is a measure of homogeneity. Are we measuring similar things or similar items regarding a particular construct? However, this test, as you can see, is a general electronic repair test, and it asks you about different things like Blu-ray players, MP3 players. It's divided into multiple sections. They are not the same, right? Your items literally are not similar. They are asking for different things. And therefore, we do not expect a high inter-item consistency in this particular test. So, that's what we mean by that. Like, inter-item is about homogeneity. So, if it's a heterogeneous test, the items are different, measuring different things, we expect a low inter-item consistency result. The BLEP 2021 is an example of A. Norm reference testing, B. Criterion reference testing, C. Aptitude test, or D. Intelligence test. The correct answer is letter B. Criterion reference test. Di ba sir may top notcher? Paano mo nasabing criterion reference test yun? Well, kasi ang nilalagyan talaga natin ng weight sa board exam is whether you passed or not. And for exams na may pass or fail, it is what we call criterion reference. Meaning, kung nakapasa ka, 75% yung average mo, meaning you have the criterion we are looking for, which is you have the qualifications to practice psychometrics in the Philippines. So it's a criterion reference test. Rule of thumb, if it's a pass or fail, criterion reference test. If it's not, you're being compared with other people, like in personality test, it is a norm reference test. The BLEP 2021 uses which of the following cutoff score? A. Relative cut score, B. Absolute cut score, C. Multiple cut score, or D. Multiple hurdles. And the correct answer is letter B. Absolute cut score. First, with relative cut score, that means yung cut score, it depends on others. Para siyang norm reference. When we say we have a relative cut score, let's say, hello everyone, I am only accepting the top 10. Top 10 lang ang papasa sa exam na to. So, yung pagpasa mo, nakadepende sa score ng ibang tao. Your tendency to qualify for that test is dependent on other people. Absolute cut score naman is yung board exam. Kasi criterion reference siya. Usually sa criterion reference, it's an absolute cut score. 75 ka on average, okay, pasado ka. Right? Hindi ka 75 on average, mas mababa ka, pagsak ka. So, multiple cut scores naman is, well, if you look at this grading system, mapapansin siya sa college, no? 75 to 79, D. 80 to 84, C. 85 to 89, B. 90 to 100, A. Or, kung nasa Lasal ka, 95 to 100, 4. 90 to 95, 3.5. So, yun ang multiple cut scores. Naka-cut siya at a certain level and then may iba't ibang categorization. Ang of method naman, it's another way of setting the cut score. It's basically on expert judgment. Ang of method, basically you have an expert and you ask them to have a consensus about what the cut score should be. Multiple hurdles is that para kang nagja-job interview, no? Una, papasa ka ng exam, maybe screening test. Pag nakapasa ka ng screening test, sunod naman, may interview. Pag nakapasa ng interview, meron pang cognitive test naman. Tapos, final interview. So, ganun ang multiple hurdles. Para ka lang lumalaktaw-laktaw. And of course, pag nag-fail ka dun sa unang hurdle, bagsak ka na. You're not accepted. And then, we also have known groups method for setting cut scores. You use a particular group, let's say, a psychometrician, and then you use another group, which is people who are not trained in psychometrics, and then you compare them with one another and use them in comparison, and then you make a certain cut score based on that comparison. So, kunwari, kung on average, kung ang pinakamababa sa mga psychometrician na pumasa, 75 dun sa test na binibigay mo, tapos ang pinakamataas naman dun sa non-psychometricians are 50. So yun, hahanapin mo dun somewhere there kung alin yung magiging cut score. Bookmark method, well, it's based on IRT-based cut score. So basically, para din siyang, based din siya sa experts, kaso bibigyan mo siya ng iba't ibang item na may iba't ibang level of difficulty, and then that booklet, the experts would bookmark that on which item they think would be the ideal for the difficulty of the test. And that will be the basis for setting up the cut score for the test. The main problem with the Angov method is A. Inter-scorer disagreement, B. Composition of the contrasting groups, C. Optimal length of item bookmarks, or D. Possible floor and ceiling effects. And the correct answer is letter A. Inter-scorer disagreement. Again, Angov method is all about what? It's all about experts, right? You're asking experts on what would they think would be the cut score for this test should be. But if they disagree with one another, now are you gonna figure it out? Right? So that's one of the main issues with the Angloff method. And for letter B, composition of the contrasting groups, that's one of the problems with known groups method. What's the ideal composition so that you can compare them optimally? We don't know. Letter C, optimal length of item booklets. Well, that's for bookmark method. And possible floor and ceiling effects, that's for bookmark method as well. Why? Because optimal length of item booklets, well, maybe you are making a booklet that is too short, that it does not really have the ideal difficulty, or maybe it's too long, that it's hard to figure out and get the people to agree on a particular cut score, right? Because again, even with the bookmark method, you are still asking the experts which item with a certain level of difficulty would be ideal. Floor effects, meaning ito na yung lowest. Kumbaga yung unang item na nakalagay sa booklet mo, sobrang dali na kahit hindi na trained, makakapasa na. Or no naman sa highest, like yung most difficult item mo, madali pa rin for the experts. Yan yung mga possible issues.